right, guys, you are on the last section of Unit 2. Nice work. This is one of the hardest sections, so make sure you are really focused in on your lesson today. Shut off your distractions, turn your music off, put your phone away, and really focus in here and get this down because it is tough. All right, it is literal equations. Literal equations. It's basically rearranging formulas. Okay, so you're going to be solving equations, but they're going to look a little different in this section. Let's check one out. All right, number one, solve each equation for x. So on number one, that is the same stuff you guys were doing in like section 2.2. Solving an equation. You probably, hopefully, are so good at these, you don't even have to think about it too much anymore. But when you are solving an equation, remember you are undoing the order of operations, so we always are working backwards. So find your variable, because when we solve an equation, we want to get the variable all by itself. So I see an x right here. What's happening to the x? Well, it's being multiplied by 2. We've got multiplication. And it's being subtracted by 6, so we've got subtraction. When we solve the equation, we're going to undo those two operations in the opposite order as we would do order of operation. So the first thing to get rid of is subtraction. In order to get rid of something, we do the opposite operation. So we're going to add 6, but if you whatever you do on one side, you've got to do to the other. And these cancel, so we have 2x equals 16. In order to get rid of that multiplication, we do the opposite operation, which is division. By 2, whatever you do on one side, you do to the other. Those cancel. And x equals 8. And we know we can always plug that answer back in to our problem and make sure our left side and our right side are equal. Okay, but that is our solution. All right, now let's look at number 2. What's different about number 2? There's no numbers, right? That is all variables. There's all variables in here, no number. So that's what we're talking about in this section. These are literal equations. We still want to solve for x, so I'm still going to circle it because I know I need that to be all by itself when I'm all done. And you're still going to solve this just like you solve a regular equation. Because remember, variables, those are numbers. Variables are just placeholders for numbers. So looking at our x that we want to isolate to get by itself, we still have multiplication because I know if I have a number next to a letter, a number next to a variable, there's multiplication between there. Same thing is true if it's two variables because that variable stands for a number. So I've got multiplication and I've got subtraction. Same two things I had over here. I'm going to undo them in the opposite order as the order of operations. So how do I get rid of subtraction? Well, the opposite operation is addition. Whatever you do on one side, go to the other side of the equal sign and do it there as well. And those cancel on the left side. And we get ax equals, oh no, wait a minute. Are c and b like terms? Can I actually add those? Nope. Can't actually add those. Those are carrots and bananas. I can't put carrots and bananas together. So what I'm going to do is I'm just simply going to write it as c plus b. And you know what else I'm going to do? I'm going to put it in parentheses because I know anything else that happens on that right side, the first thing I have to do is add c and b. So I'm going to group them to make sure that is always the first thing I do. All right, going back, we're trying to remember what we're doing. Our goal is to get this x by itself. The other operation we had is multiplication. In order to get rid of multiplication, we do the opposite operation, which is division. Divide by a. Don't divide by x. X is what we're getting by itself, so leave that there. Divide by a. C plus b on the right side, remember that's all grouped together, so whatever we do has to be done to the whole thing. So we're going to divide by a, all of that side. Well, our a's cancel, and we get x equals, oh, wait a minute, can I actually divide this? Nope, I sure can't. So all I can do is rewrite this, and that right there, that's your answer. That's your answer. How weird is that? You are not going to get a number for your final answer. It's going to be a bunch of variables, and that is okay. That is what we're trying to do. Because remember what we said, we are rearranging formulas. So this formula used to be solved for c. It was equal to c. But now this formula is solved for x. Are there any differences in how we solve these? Well, our first step was to add. Our second step was to divide. Did we add by different things? Yeah. Did we divide by different things? Yeah. But can you see, looking back at the original equations, how similar they are? If I would let A be a 2, B be 6, and C be 10, I'd have the exact same thing. Okay, so this is just a problem without all of those numbers in there. And in fact, here's the crazy part. It's actually a little bit maybe easier because I didn't have to do any of these operations. I didn't actually have to calculate 10 plus 6. Not that that would be hard to calculate, but I didn't even have to do that. I didn't even have to actually divide 16 by 2 to get the 8. I just left it as C plus B and then divided by A. So some of you guys solve a problem completely correctly, but then mess up on your addition or your subtraction or your division. You're not going to make those mistakes here. So that's a bit of an advantage. Okay, now solve the following equation for A doing the same exact way. Same type of thing. So if you look, ax minus b equals c, that's the same problem we're going to do. Last time we solved it for x, now we're going to solve it for a. Okay, so I'm going to write this down again to remind ourselves we always undo in this order. So what do we have here? Look at the variable you are solving for. I would suggest you always circle it. What operations are being done to the a? Well, I'm multiplying by x, and I'm subtracting b. So check mark your operations, and then, oh my gosh, I don't know what to do first. I have no idea. Oh, but wait a minute. Yes, I do, because all I'm going to do is PEMDAS in the opposite order. So please write this down if you're stuck and don't know what to start with. This is going to tell you. Subtract first. How do I get rid of subtraction? I do addition. Whatever you do on one side, you do to the other. Those have canceled now. Negative b plus b is 0, so that's gone. And remember over here, I can't actually add those. They're not like terms. They're not the same variable. So all I'm going to do is write c plus b. And I'm going to group it to remember that whatever else I do on that side, c plus b was the first thing that needs done. The multiplication is the last thing to get rid of. In order to undo that, I'm going to divide by what? Which variable do I want to solve for? A. A is what I want by itself, so that means I need to divide off the x, and I have to do that on both sides. Everything over here being divided by x. So we get A equals c plus b divided by x. Remember, variables are just placeholders for numbers. So we solve the same way. We solve regular equations. It's nothing different. It's just there's variables instead of numbers. So how is it different from the other equations? What did we just say? There are variables instead of numbers. You have to, in your head, almost imagine those are numbers and think about it that way. How are the solutions different? Well, you don't have to do the computation. You're just going to leave all those variables over there. This is used, solving these formulas is used the most in science class. In math, we don't do it a whole lot, to be really honest. And I'll show you at the end where we do use it. But this is more applicable in science class. And every year, science teachers say, don't these students know how to solve these formulas? Don't they know how to do this? And I say, well, they do, but it's something that we don't use a lot in math. It's more applicable in science. So get this down. Your science teachers will be very happy. All right, there's your hot tip. Make sure you write it down. We've said it several times. When you're solving equations, you are undoing. So you perform PEMDAS backwards. Number 4, area of a triangle, we want to solve for b. Whatever variable you are solving for, please circle it. Then write down PEMDAS and mark whatever operations you have. So what is happening to b? B is being multiplied by 1/2, and it's being multiplied by h. So the only operation we have to undo is multiplication. However, one of the things you're multiplying by is a fraction. One option to get rid of multiplication by a fraction is to divide by that fraction. But dividing by fractions gets messy. So what I would always suggest you do, instead of dividing by a fraction, multiply by the fraction's reciprocal. Remember that? Remember that that's the same? So if I multiply this by the reciprocal of 1/2, that would be 2 over 1. Whatever you do on one side, do to the other. Well, 2 over 1 is just 2, and 2 times a is 2a. 1/2 times 2, that becomes a 1. That cancels, right? You can cross cancel these things. Well, 1 is just, we don't need it, so we just have BH. Okay, then take your B, remember that's what you're solving for. And how are we going to get it alone? Well, the other multiplication by h can be gotten rid of by dividing by h. So we get 2a over h equals b. Okay. Complete side note here. Say we had a equals 4bh. This is not a formula for area of anything in particular. But if I had that and I wanted to get b by itself, I could just divide by 4h here. Okay, so you can divide by more than one thing, even if they're not right next to each other, because this is still multiplication and the order doesn't matter. The reason I did not do that in my original problem here is because then I would have had a fraction and a fraction within each other, and that's not always preferred. So if you can avoid that, it's nice to avoid it. Number 5, perimeter of a rectangle, solve for L. Okay, so here is what I am solving for. Let's talk about, I wrote over that parentheses, let me rewrite that. Let's talk about what's being done to L. I see some addition happening. I see some grouping, some parentheses, and then I see some multiplication. So this you really got to think about here. Because this is grouped together, you have to undo anything before or outside of the grouping first. So outside of that grouping is the multiplication. So even though that is not the first thing when we go backwards, that's the first thing outside of the grouping. So you could actually kind of think of it as within the parentheses, what is happening? You have addition. But outside of the parentheses, okay, so out of the parentheses, this is in the parentheses, out of the parentheses we have multiplication. You have to undo the stuff that is out of the parentheses first. So that means I have to get rid of times 2 first. Get rid of times 2 by the opposite operation, divide by 2. So I've got p over 2. Notice how when I wrote this, I divided everything. Anytime you're multiplying or dividing, you do it everywhere. Okay, addition, subtraction is only with the like terms. Multiplication, division is everywhere. That's something you guys seem to struggle with on 2.2 as well. So make sure you get that here. Those are gone. I have L plus W. Now, if I'm looking up here, I've now taken care of everything outside of the parentheses. I've done everything here. So now I can work inside the parentheses. And the only thing inside the parentheses is addition. In order to get rid of, I'm trying to get L by itself, so in order to get rid of plus W, I'm going to subtract W. So now I have isolated L, and what is it equal to? P over 2 minus W. Okay? So the advantage to doing these is now if you were given your perimeter and your width, you could find your length super quickly, very easily. And that is something that's useful in science. If you guys are solving D equals RT and you have the D and the T and you want to solve for the R or things like that. So in science class, this is utilized quite a bit. Maybe you guys have already been doing it, I'm not sure. Okay, we've got a formula for interest, like interest at the bank. Solve for the given variable. So here's the formula, A equals P times 1 plus RT. We want to solve for P. So I'm going to rewrite that formula, and I am going to circle what I am solving for. okay? Order of operations, I'm going to write it down, and I'm going to mark all of my operations. Well, remember, we have to work with things that are outside of the grouping first. But if you look, what's outside of your grouping is exactly what you want to solve for. How is that connected to the grouping? It's multiplication. So the only thing that's actually being done to the p is multiplication by this whole group. We don't care that there's addition inside there because it's just being multiplied by the p. You're not actually adding anything to the p. You're not subtracting anything from the p. All you're doing to p is multiplying it by this big quantity. Kind of weird to think of it like that because you see addition. You think, oh, yep, there's addition. But there's not. That addition is not happening to p. We only want to mark things that are happening to p. The only thing that's happening to p is multiplication, so we have to divide. What are we dividing by? Everything that's being multiplied by p, which is the whole quantity, 1 plus RT. Well, if I do that then, multiply by 1 plus RT, divide by 1 plus RT, those cancel. So I get my p all by itself, and I have on my other side a divided by 1 plus RT. There you go. Okay, same equation, but now this time we want to solve it for t. So I circle what I'm solving for, and I think about my order of operations. What's being done to t? I see multiplication. I see addition, and that's all within the grouping. Separately, let's talk about what's happening outside of the grouping. So that was in the grouping, in the parentheses, and this is going to be out. Out of the parentheses, all I have is multiplication. In a normal order of operations, you do what's in the parentheses first. But because we are working it opposite when you're undoing an equation, you're going to work on the outside of the parentheses first. So how do I get rid of or undo times p? I divide by p. Those now are gone. A over p equals 1 plus RT. Okay, so I've completed this one. Now up here, what's the next thing to undo? A lot of students would look at this and they'll be like, I don't know what to do next. Write out your PEMDAS. Mark what's happening to the variable you're solving for, and then work it backwards. Undo subtraction, or I'm sorry, addition by doing subtraction. So how do I get rid of 1? I subtract 1. A over P minus 1 equals RT, because those have canceled. And my last thing to undo is multiplication. I undo multiplication by division. What do I divide by here? What variable are you solving for? You're solving for t, so divide by the other one, r. Okay, so I've isolated t. What do I have over here? Well, I've got a over p minus 1 all over r. And I said before, it's not really preferred to have a fraction over a fraction, but on these problems, guys, I'm going to let it go. Okay, it is perfectly fine if you've got a fraction being divided or a fraction over a fraction. For these problems, that is okay. All right, here's 2 problems for you. I want you to pause the video and you guys try them. Pause the video, try these. You're using this yellow equation for both. Solve it for y the first time, solve it for x the second time. Give it a shot. All right, let's check them out. The first one, solve for y. I circled what I was solving for, and I wrote down what was happening to y. So what I see happening to y is multiplication, right there, multiplication. And notice I checked addition. Sometimes students will say, oh, but it's being subtracted. You're subtracting 3x. No, you're not. You're not subtracting 3x. You are adding 3x. There is an invisible plus sign right here. Okay, that minus sign is with the 4. So you are multiplying y by negative 4, but then you are adding 3x. So make sure you understand that. Undo your addition first, which is by subtracting 3x. Then undo your multiplication of negative 4 by dividing by negative 4. And then I went ahead and simplified that. So we call it that little heart problem. It's just distributive property with division. 12 divided by -4 is -3. But then you also have to divide here. Because remember, when we multiply or divide, we do it everywhere. -3 divided by -4 is +3/4, and I stick that x with it. There you go. On the right side, solving for x, what's being done to it? Multiplication by 3. And now you are actually subtracting 4y. So then we add 4y first, and then we divide by 3, do the division on each piece, and you get this answer. Okay, notice they're not the same, right? Two different answers because we solved for two different variables. And this right here, guys, this is where we start using it. Okay, in the next unit, you're going to have problems that look like this, and most of the time you're going to want to solve them for y. Sometimes you'll solve them for x, but you will also mostly want to be solving them for y. Okay, so do we use this? Yes, we do, but we don't always, in math class, we're not always doing these ones that are like all variables. We tend to be using them on these, which, if you recognize that, is the equation of a line. Right, we normally work with it in y equals mx plus b, so we will still have some rearranging here, but that's where we're headed to use these. Okay? All right, work hard on this section. Do not copy a single thing. You need to do this work on your own. It is hard, and it will only be harder for you if you don't practice it. Good luck, guys.